Welcome to Daemon Automation's Factory Floor AI podcast series.
We are looking at the world of high-speed industrial automation. Today, we're tackling, I think, one of the biggest headaches for any industrial manager. How do you guarantee safety compliance? 24/7.
It's the ultimate accountability problem, isn't it? Because right now, so many places rely on, manual monitoring, and that's just inconsistent.
It's prone to human error, fatigue. If you're not physically standing there, how can you be sure that brand new safety program is actually being followed?
You can't. And that's the thing. We have systems that are great at telling us when a machine might fail, which is what Daemon AI has been focused on, preventing downtime.
Right.
But this is the next step. It's about behavior. Are people wearing their PPE? Are they following the SOPs, especially when they think no one's watching?
And that's exactly why we're digging into the architecture notes for the upcoming Daemon AI 2.0 release. We've got the chief software architect's notes. We're looking at current research.
We're basically going to see how they're engineering a system to guarantee that safety adherence.
So let's start with that foundation. Why is this technology even necessary? It really begins with that inconsistency problem.
The sources are pretty clear on this. Human oversight has built-in inconsistency. You just can't be everywhere at once, especially in these huge machinery-dense facilities.
Or on the night shift.
Exactly. Supervision, it thins out dramatically after 5 p.m.
And that creates a huge variability in risk. You might feel great about compliance at 10 in the morning, but what about at 2 a.m. during a shift change? That confidence just evaporates.
So Daemon AI's answer to this whole problem is to build it on an industrial-grade edge AI platform.
Right.
But this brings up a pretty big question for a manager listening to this. Cloud is cheap, it's scalable. Why would I pay for expensive, dedicated hardware on-site? And that's a great question. It really comes down to your tolerance for risk. For something like, inventory tracking, the cloud's fine, a little lag doesn't matter.
But not for safety.
For safety, it's a zero-tolerance game. If a worker steps into a restricted zone, 100-millisecond delay waiting for a signal to go to the cloud and back could be the difference between a warning and a catastrophic incident.
So the core advantages are really resilience and speed.
That low latency is everything for real-time enforcement. You need that instant detection.
And to get that speed, the architecture notes say they're leveraging some serious dedicated hardware. We're talking high-end GPU and CPU power right there on the factory floor. And they're not just relying on the hardware, they're accelerating the software itself.
They are. This is where we should probably talk about Tensor.
Okay.
So think of a standard AI model, maybe built in PyTorch. It's powerful, but it's a bit like a general purpose engine.
Gets the job done.
It gets the job done. But TensorReady is like installing specialized racing software on that engine. It strips out everything unnecessary and fine-tunes the model for one thing and one thing only: deployment speed.
So you're not changing what the model does, you're just making it execute insanely fast.
Exactly. The notes claim a 2 to 3 times faster inference speed compared to running the standard model. That is a massive gain in performance.
And that performance allows for scalability. Because one camera is useful, but it's not a full solution.
Right. And their runtime layer, it's built for multi-threaded processing. It can handle up to 9 cameras at the same time, all with optimized memory.
So you can cover a whole production line, multiple angles, multiple risks, without needing 9 separate supercomputers to run it all.
That's the idea. That's scalability on top of the low latency edge compute. That's what creates the foundation for a true compliance system.
Okay, so we've established the foundation is fast and it's resilient. But that brings us to the next big question. Precision. Generic systems just aren't going to work for complex manufacturing, right?
Not at all. And I think a good way to think about it is, it's like building a specialized vehicle.
Okay, I like that. So not a mass-produced car.
Exactly. You've got companies, camera manufacturers, security companies. They're trying to build the best standard car. Your Toyotas, your Hondas. And they're great for most people.
But what if you need something different? Something for a really specific, tough job that a standard sedan can't handle.
That's where Daemon AI is positioning itself. They're trying to fill the gap where those standard systems fail. They're building the specialized vehicle for the factory that has a unique problem to solve.
So they have to move beyond just person detected to something far more tailored.
Yes, tailored to very specific standard operating procedures, or SOPs.
So how does Daemon AI 2.0 actually do that? What are the specific computer vision techniques they're using?
They're using proven core techniques: object detection, or OD, and image classification, which you might hear called a CNN, a convolutional neural network.
So object detection finds the person and say, their helmet.
Right. And then image classification can look closer and classify if that helmet is being worn correctly or if it's the right type of protective clothing for that specific task.
But safety needs change from one spot to the next. The PPE for a maintenance task is different from production, even if they're only 20 feet apart.
And that's where the system's multi-model flexibility is really the brilliant part. It supports both formats, those super-fast tensor root engines and standard PyTorch models. And this is the key, it lets you configure up to 8 different specialized models for every single camera.
So a single camera isn't just looking for helmet or no helmet.
No, it could be simultaneously checking for 8 different, totally separate compliance rules, all based on what's happening in front of it.
So it can customize the inference on the fly.
Instantly. In Zone A, it might be running Model 1 for hearing protection. But if the work shifts and a different process starts, the system could dynamically swap to running Model 5, which checks for, say, specialized safety harnesses.
That level of specific configuration is what lets you tackle those niche risks that a generic system would just completely miss.
Right.
Let's make this real. How would this apply in, say, the wood products manufacturing sector?
Oh, that's a perfect example. It's heavy industry, lots of unique high-risk processes. Imagine an area where they're processing wet wood veneer. You need safety glasses. But what if that veneer is dry and dusty? Suddenly the risk changes. You don't just need glasses, you might need specialized respirators and full-face shields.
So the system could see the material has changed, recognize the new risk from airborne dust, and immediately check if the worker has switched from glasses to the required full shield.
And flag a non-compliance violation in real time if they haven't. Or think about material handling. Improperly stacking heavy lumber is a huge risk.
Right, it can be really unstable.
So the system can be specialized to verify not just that the worker has their helmet on, but that they're stacking the material at the correct angle, following the SOP to the letter.
That's the real value. It's real-time, objective enforcement of very specific rules. You're not just reviewing footage after a near miss.
That specialized instantaneous check.
Yeah.
That's the game changer.
Which is the perfect lead into our final segment. How do you take these precise insights and make them truly actionable for the factory's control systems?
Getting an accurate result from the AI is one thing. But getting a result that a manager trusts enough to actually automate an action, like stopping a machine, that requires a different level of reliability.
And how is that managed?
It's managed by a really critical feature in the Daemon AI pipeline. It's called the simplified conditioning system.
Okay, the conditioning system. What problem is that solving for a manager on the floor?
It solves the problem of noise, false alarms. It's what we sometimes call PLC chatter, these rapid flickering signals that aren't real violations, but they make the control system and people very nervous.
So if the AI gets a brief millisecond flicker of a detection, maybe a helmet is blocked from view for just a moment, how does the system filter that out?
It's basically a skepticism filter. It requires a set number of consecutive identical results above a certain confidence score before it will trigger a real alert.
So the non-compliant state has to be sustained. It has to be real.
It has to be real. This stabilizes the AI's predictions and ensures that when an alert does go out, it's something you can trust. It eliminates chasing ghosts and rebuilds trust in the automation.
And that trustworthy output then gets sent where?
It's routed through their comprehensive bidirectional PLC communication. Daemon AI 2.0 is built to speak the language of the factory floor, to talk directly with Allen Bradley PLCs and other controllers.
So the vision system isn't just a passive observer anymore.
No, not at all. It's an active participant in the factory's control loop.
It's sending alert codes and inference results to the PLC. But you said bidirectional? What's coming back from the PLC?
That's the other half of it. The PLC can actually exert control over the AI system.
Give me an example. Why would the PLC need to control the vision system?
Well, the PLC knows the state of the entire machine, so it can command the AI into different modes. It can trigger a run mode or an ignore mode if there's, say, an authorized maintenance workaround happening.
Okay, that makes sense.
But most importantly, it can trigger a save mode.
A save mode commanded by the PLC.
The PLC can tell the AI system, hey, something just happened, a sensor tripped. I need you to save the video from your ring buffer right now.
You get video evidence triggered by the AI's own predictions, but also by physical events on the machine itself.
Exactly. It guarantees you capture the context around every critical event and near miss without having to save and sift through 24 hours of useless footage.
That control over the video archive sounds essential for audit trails and documentation.
It is the ring buffer recording with the automatic alert triggered MP4 saves. That's the objective, indisputable evidence you need for reporting, for audits, for training.
And all of this data gets visualized in compliance dashboards. How does that help a manager make better decisions?
It shifts them from being reactive to being proactive. They can see real time alerts, but more importantly, they can see trends. They can visually identify risk hotspots, an area or a shift where non compliance keeps happening.
So you can target your training and your supervision exactly where the data shows it's needed most.
Precisely. It streamlines everything.
So if we tie this all together, what Daemon AI 2.0 is delivering is this continuous, objective view of compliance. It's built on the speed and robustness of Edge AI. It gets its precision from those specialized multi-model vision systems.
And its reliability from that very clever conditioning system that filters out the noise.
It really feels like a fundamental shift in how industrial safety is managed.
It is. It takes monitoring from something that's subjective and periodic, relying on someone's memory and presence, and grounds it in a foundation of continuous, objective, data driven proof.
That objectivity has to be invaluable for liability, for training, and for just creating a genuinely safer workplace.
That shift from subjective checks to objective data collection really is the defining feature.
I think the key takeaways for you are twofold. First, compliance monitoring is no longer a passive thing. It's not an end-of-day report. It's active, customized enforcement based on the specific job someone is doing. The second is that the convergence of these smart AI vision engines with industrial PLCs allows a safety violation to trigger a physical real-time response. You're building safety enforcement directly into the machine's automation, not just sending an alert to someone's email.
We've just spent this whole time talking about how industrial AI can measure human actions with incredible precision. So that raises a much bigger question for any manufacturer listening. If you can use this level of continuous, objective data to perfect your human safety compliance procedures, what happens when you turn that same precision on every other variable within your standard operating procedures?
You're not just ensuring perfect safety compliance. You're using that data to ensure perfect, repeatable product quality every single time. That is definitely food for thought. We hope you feel thoroughly informed about the future of specialized Edge AI safety compliance.
To learn more, visit daemonautomation.com.